Hi guys, welcome to another episode of MrLopezClasses.com. In this episode we are going to talk about Marine Autopilots. This is the chapter 15 of your Marine Electronics book. In this chapter we are going to talk how the autopilot works and how to install the autopilot in a typical medium or mega yacht, and the different type of autopilots, the different type of servo cylinders, and some tips for installation and troubleshoot of autopilots. Welcome to this fascinating equipment, the autopilot. In my opinion, the autopilot is a robot. It's a perfect robot. Why? Because the autopilot integrate hydraulic systems, electrical systems, electronic systems, and mechanical systems. All of those systems integrated in one central equipment, in one intelligent equipment, the autopilot. Okay, we are going to check the theory related with the autopilot. The autopilot is a mechanical, electrical, or hydraulic system used to guide a vessel without assistance from a human being. The majority of the people understand the autopilot refer to the aircrafts, but no, the autopilot today are very common in the automotive industry, in the marine industry, of course, and in other industries. The autopilot is every day more and more and more popular, and specific in the marine field, the autopilot every day is more sophisticated. The autopilot of today is completely different like the autopilot of 10 years ago, and completely different like the autopilot of 15 years ago. Every year when I visit the boat shows in different parts of the world, I found that the pavilion with more inventions, with more innovations, is the stand of electronics. And I found that in the stand of electronics a lot of innovations, but one of the equipments with more and more innovation year by year is the autopilot. Also the radar. The radar is incredible. The advantage every year by year. Okay, we are going to check the components of the autopilot, and we are going to study each component in particular, and after that, at the end, we are going to integrate all of those components in order to install the autopilot in a typical boat. Alright, the components of the autopilot. The autopilot consists of the display. This is the main display in this particular case. This is the display for the boat completely. In this display I have integrated transducer, I have integrated autopilot, I have integrated a GPS, I have integrated radar, I have integrated VHF radio. All of the systems are integrated in this central display or central computer or central unit or CPU. All of the equipments are connected with the NMEA backbone. The NMEA backbone is the spinal dorsal of this system, and all the equipments are integrated on the backbone. This is the main screen. This is the first component of the autopilot system. In some cases there are auxiliary screens like this. This is another screen. Probably this is the main screen located in the pilot helm, and probably this is the secondary screen on the fly bridge, yeah, or on the deck. You can install all the auxiliary computers, the auxiliary screens that you wanted. The display, the control unit, and other important equipment is the hydraulic unit or the drive pump, the central hydraulic unit or drive pump. This is other important equipment. The processor or computer, that's the computer. This is the computer that integrates all the sensors with the backbone. This is the computer 10 years ago, and this is the computer, the same manufacturer. I love Marine. The same manufacturer today. This is more sophisticated in comparison with both of them. Produce the same function, but this is the last version, and this is the previous section. This is the computer. The computer integrates the sensors. The rudder sensor. This sensor is connected in parallel with the rudder arm, like you have on the screen right now. The sensor and the rudder arm. The sensor and the rudder arm. The rudder arm work in parallel with the rudder sensor. The compass. This is the compass. The compass is integrated also on the computer, and the computer connected with the backbone, and the backbone connected with the main screen. At the end of the day, all the sensors, this is the compass, rudder sensor, this is the compass NMEA 183, and this is the last version of compass with the outlets to connect, one on the power and other one on the backbone. One on the power and other one on the backbone. This is the new sensor. The sensor should be located vertical according with the arrow. We are going to show later that procedure. The sensor, compass, rudder sensors, and this is the servo cylinder. This is an electrical servo cylinder. There are electro-hydraulic, electromechanical rudder sensor like the sensors on the screen, or this one. This is the rudder actuator, the actuator or servo cylinder. This servo cylinder is connected directly into the computer in the position motor. We are going to check later where should be connected this servo cylinder. The servo cylinder is at the end of the equation the element that correct the steer of the boat, correct the direction of the boat, because this element, this end, is connected with the rudder arm, like the screen, like the picture on the screen. Yeah, this is the servo cylinder, and the servo cylinder should be used to correct the deviation on the rudder arm. Okay, those are the elements, and those elements are integrated with the power steering system. Those elements are integrated with that hydraulic, mechanic, power steering system that we are going to check right now quickly. You can check my videos related with the power steering system in the auxiliary book, the chapter dedicated to hydraulic system, power steering system. In that book, I explain with more details the power assisted hydraulic units. Right now, we are going to talk about the power steering system, the power assisted units, how they work integrated with the Autopilot, and how is the troubleshoot with that units. The power steering system, and we are going to verify how is important a good power steering system. I recommend hydraulic. Can I install an Autopilot in my boat with mechanical steering system? Yes, you can. You can. With mechanical system, it's possible. It's better with hydraulic. Yes, it's better. It's better with hydraulic system because it's more accurate, and you have a less play, and you have a better response. All right. I mentioned Teleflex because Teleflex is an excellent manufacturer of power assisted unit, hydraulic units, and power steering systems. Teleflex is a good company, and I use those products constantly. The a.c.r hydraulic steering system is designed to provide the extra margin on the muscle when it's necessary. The a.c.r system easily handles outboards, steam drive, or inboards. System is simplified with the use three major components. The first one is the helm. The second one is the cylinders. And the third one are the lines, the pipes, the connections in between the helm and the cylinder at the end. This is a typical hydraulic steering system. This is a typical hydraulic steering system, and we are going to check right now the components of that system. All right, in the picture you have the basic hydraulic system for in this particular case for a dinghy boat. If you check in this picture, we have the helm. This is the helm located here, and the pump is located over there. Those are the lines, and here we have the cylinder. That's the cylinder. This is a special cylinder. This is a cylinder double action, double force. This is a cylinder double action, and double force. This is the cylinder normally used in a steering system, in power steering system. We are going to talk in the book of hydraulic system in details about those cylinders and the difference between this one, double action, double force, or single double or double single. Depends, and we are going to study those cylinders in that book, in the hydraulic book, in the auxiliary book. All right, we have the cylinder, we have the lines, we have the helm or pump. On the helm is located the pump. Right now we are going to talk about the pump. All right, this is the most simple system. This pump is moved by the wheel. When the wheel is moving, this pump produce maximum 60 psi, maximum, but normally is around 35 psi. This is the pressure of this manual pump. This is the pump. The pump is located here on the helm. You have the wheel, and in the bottom of the wheel is located the pump. And the pump have the reservoir integrated. The reservoir is located here. You can add the fluid here at the reservoir. That's the reservoir, and this is the wheel. Right? This is the pump. It's a mechanical pump. It's a mechanical hydraulic pump. It's mechanical because you activate the pump with your hand. When you move the wheel, the pump is activated. The hydraulic pump or helm pump is a mechanical pump. The wheel is located here. Produce the mechanical movement. When the mechanical movement is produced, the rotation activates those servo valves or body valves located here. And here in this area is located the compartment. For that reason, you have the cap to fill the hydraulic liquid here. You fill the liquid, and right now the reservoir is full of liquid, and the body of valves is ready to receive the fluid when the wheel is moving in one direction or other direction. This port is connected with the starboard side, line, and the other port is connected with the port side line. The port side and the starboard side is connected here and here. The bottom one in the middle, this one, is the return. The return is used to return the excess of fluid into the container on the reservoir. And right now we are going to talk about the reservoir. This is the helm pump. The helm pump is divided into the reservoir for the liquid, and the body of valves here where the servo valves are located. One valve to control the flow in one direction, and other valve to control the flow in other direction, port side and starboard side. When the wheel is moving in this direction, the fluid is going out here and return over there. When the wheel is moving in the opposite direction, the fluid goes out here and return over there. It's too simple. And the return collect the excess of fluid into the reservoir. If I have a simple boat, like the boat that I have on the screen right now, in this boat, if you check, I only have the helm pump and I have the cylinder in the back, but I don't have in the middle. I don't have reservoir. What is the advantage of the reservoir? This is the reservoir. That's the reservoir that is located on the screen right now. The reservoir is important for three important reasons. In in the reservoir, I have the marks to indicate the level of the fluid and also to indicate the color of the fluid. This is critical. The color of the fluid and the level is critical. Normally, the fluid should be located in the middle of the second window, the top window. In the middle of that window, the fluid should be located. And the rest in this area, in this compartment, should be full of air. Air, yeah, because the air pressurizes the system. For that reason, in this container, in this cylinder, you have a valve here, like the valve that you have in your bicycle, in order to introduce air with the hand pump. And normally this system works with 35 psi, in between 30 and 35 psi. This is the pressure, the operational pressure of this typical power steering system, 35 psi. Okay? This is the reservoir. The level of the reservoir should be here. Those windows are important in order to verify that the fluid is in the appropriate level, and also that the color of the fluid is the normal color of the fluid. Normally in those hydraulic power steering systems, the color is like a yellow, is clear yellow, or red, because some people prefer use automatic transmission fluid, red color. This is a good choice. The automatic transmission fluid have a good quality, good detergent. Those detergents not affect the cylinders, not affect the O-rings of the systems. Or if you wanted to use it, the hydraulic fluid recommended by the manufacturer is like a yellow color, is good. No, that's your decision. And also, I recommend always follow the manufacturer recommendation. If the manufacturer of your hydraulic system recommend that specific oil, use that oil. That's the most important part. Follow the manufacturer recommendations always. Okay? The cylinder is good for to check the level of the fluid in order to verify that I don't have leaks. What happens if suddenly the level of the fluid is here? I have a leak. No, I don't have leaks. You have a leak. You have a leak. Normally, if you have a leak, what is the symptom? Suppose that you check in the boat and you no leaks, but the level is down. It's because you have a leak. You need to verify carefully and you find where is the leak. When you have a leak of fluid, normally the steering wheel is moving soft in one direction and hard in the other direction. Not hard in the other direction. Or is moving with intermittent movement in one direction and soft in the other one. This is because you have a leak and you have air on the line. This is a typical consequence. We're going to check later that. Alright, the reservoir is good to check the level, to check the color, and it's good to keep pressurize the system because you introduce air with pressure over there in that area and you pressurize the system. What is normally the pressure operation for those systems? In between 30 and 35 psi. This is the operational pressure. Of course, once again, depends on the manufacturer. Hey, Mr. Lopez, I have a system that operates with 40 psi. Okay, this is the recommendation of that specific manufacturer. Follow that specification and keep that gauge in 40 psi. Okay, follow the manufacturer recommendation. This is the function of the reservoir, and it's very important. If I have a boat like this, like the boat that you have on the screen, can I install a reservoir over there? Yes, you can. It's simple. And finally, if you install the reservoir, the situation is like this. You need cut the port and starboard lines, and you need insert in series the reservoir. If you check this picture, we have the port side. This is the port side. This is the starboard side. And you cut the lines and you insert in series the reservoir, and you continue with the port side and starboard side line connected into the cylinder. It's too simple. Once again, let me show to you in this particular example. Those are the lines, port side and starboard side, coming from the bottom from the hand pump. The port side and starboard side are cut. I install the fittings. I connect in one side of the reservoir tank, and from the other side I continue into the cylinder. I interrupt the lines and I insert my reservoir. And I connect the return connected into the return of this equipment that we are going to talk later. All right. If I don't have this equipment, I connect the return of this into the return of the hand pump. When I have this equipment, if I have that equipment, I have two options. I can install a T here with a one line for this return and other line for the return of the power assisted unit. This is an option. Or you can return directly here. But the recommendation is install a T over there, one line to return here and other line to return over there. All right? Okay, this is the procedure to insert the reservoir. The most important part when you install a reservoir is prepare, fabricate the fittings appropriate for those hydraulic systems. Those fittings are special fittings. Those fittings are the fittings recommended by the manufacturer of this hydraulic reservoir. Those fittings are available in a hydraulic storage. I love hydraulic supply. There are millions of hydraulic storage, and they supply the appropriate fittings for those reservoirs. Okay, this is the function of the reservoir. Three functions: keep the pressure in the system stable because you pressurize to the valve with the hand pump, and keep the level of the fluid appropriate, and check if the color of the fluid is clean. If the color of the fluid changes suddenly, is for two reasons. Normally, it's because water entered in the system. This is one of the reasons. And other reason is because the pump is damaged, the O-rings are deteriorated, or the pump, the servo cylinder is damaged, and the O-rings are deteriorated and degraded. Probably because the fluid that you added on the pump is not the appropriate fluid, and the fluid degraded the O-rings and the material of the gaskets. And for that reason, the color of the fluid right now is different. This is important. Once again, in other videos I mentioned, be familiarized with the odor of the fluids. Be familiarized with the odor of the coolant, the odor of the electrolyte of batteries, the odor of the motor oil, the odor of transmission oil, the odor of hydraulic oil. It's completely different. It's a special odor. This is important that immediately you open the door, the hatch of your engine room, only with the odor you identify if you have a leak. Oh, smell like a coolant. I have a leak of coolant in any of the engines or generators. It smell like hydraulic. I have a leak probably in a power steering systems or in the central hydraulic unit of my boat. It smell like a battery acid. Oh, probably I have a group of batteries with one battery in short, and the battery is boiling, and the electrolyte is evaporated, overcharging, and smell like acid. Yeah. Oh, I smell like a motor oil. I have a leak in one of the engines, one of the generators. I have the odor of transmission oil. You need to be familiarized with the different fluids in your boat. This fluid in particular have a special odor. Is easy to identify. All right, this is the function of the reservoir, and yes, it's very important. Install a reservoir. It's simple. You cut the lines, starboard and port, and you insert in series. Quiz question. You insert in series the reservoir on the system. Or if I have an autopilot system, is necessary to install the reservoir? Yes, it's mandatory because the level of the fluid, the quality of the fluid is a very important factor in the installation of an autopilot system. This is another example of an outboard system. This is the helm. The reservoir, you check the return line connected with the helm and the cylinder in the back. Those are different type of boats with a reservoir located in between. The reservoir is critical, I recommend always install a reservoir. All right. In this particular example, this is a boat with a dual station. One station, one helm on the fly bridge, and other helm on the pilot helm. Both helms are connected. Let me explain quickly what is the procedure to connect this. Look at this helm pump. In this helm pump, I have one port for port side line, other port for starboard side line, and I have in the bottom one port for the return in order to connect the return with the reservoir tank, and this one is other part to install a T and connect the upper unit or lower unit. You can install other unit, other hand unit on the fly bridge, and you use that port to go up into that connection. And the connection is like this. It's exactly like this. You see, you install this over there, and you connect this helm in parallel. In parallel with the top one. That's okay. All right. I have I want to introduce this picture. This picture is nice because it's the typical. This is the typical power steering system in a typical boat with two inboard engines with two rudders, two inboard engines, and two helms. One on the fly bridge, other on the pilot helm. And this is the reservoir of the fluid. They added one filter for the oil. This is good idea. And they added other important element is the heat exchanger. That's the heat exchanger in order to keep the fluid of the hydraulic system properly refrigerated, properly cooled. Yes, we are going to check in other of our episodes, in the episodes related with the heat exchangers in diesel and gasoline books. I recommend visit my webpage and check on the diesel book or gasoline book the episodes related with the heat exchangers. And yes, in a typical, suppose we are going to talk about the diesel engine, typical diesel engine for a medium boat. We are going to check how many heat exchangers I have in a typical diesel engine. Try to think in the diesel engine, and we are going to refresh the concept, and we are going to think how many heat exchangers I have in a typical diesel engine. Yes, I have one heat exchanger for the coolant, correct. One for the coolant, other one, or the motor oil, yeah, the oil cooler for the engine oil, perfect. And other one for the transmission oil, 3, perfect. Other one, coolant, motor oil, transmission oil, yes, for the fuel. Remember, the diesel, 80% of the diesel coming from the fuel tank return into the tank, return with high temperature. For that reason, when the fluid return into the engine, return with high temperature. For that reason, you need to install a heat exchanger in order to cool the fuel, in order to avoid vapor lock. We are going to study later in the class of diesel that situation. Yes, number 4 is for fuel. Other one, heat exchanger for coolant, heat exchanger for motor oil, hydraulic oil, heat exchanger for fuel, and other heat exchanger for the air, the intercooler. You remember in diesel engines, in order to avoid vapor lock, you need to avoid that the air enter in the combustion chamber with excessive temperature. Remember, the operational temperature in the combustion chamber when the engine is running in normal conditions is around 1075 degrees Fahrenheit. If the air coming from the turbo is coming with high temperature, enter in the combustion chamber and pass the limit of 1000 degrees Fahrenheit and produce vapor, and the vapor produce vapor lock and destroy the valves and everything, blah blah blah, right? Yes, normally in a typical boat you have 5 heat exchangers. And other heat exchanger, the last one, the number 6, is dedicated for the power steering system. The power steering system of the boat, the liquid, the hydraulic fluid is refrigerated with the heat exchanger number 6. This is the heat exchanger number 6. That heat exchanger could be connected to the starboard engine or to the port engine in order to keep the oil of the power steering system as low as possible. All right, this is the typical installation of the power steering system. And let me show to you this one. This is the actuator. This is the cylinder. This is the cylinder, the steering cylinder. That one, exactly like this. And the other one is a servo cylinder. This is a servo cylinder. In this particular case, it's a hydraulic servo cylinder. It's a hydraulic servo cylinder. This servo cylinder is like this, my friends. This servo cylinder is like this. This one is not hydraulic. This one is electric servo cylinder. In this particular case, in this electric servo cylinder, the signal is coming from the computer of the autopilot. When the computer receives the signal from the GPS, the computer calculates how much is necessary adjust the rudder, and this element is connected with the arm of the rudder, like the screen, like the picture that you have on the screen right now. This actuator, electro servo cylinder, is connected with the arm of the rudder and steer the boat in the direction that you want. Okay, this is electro servo cylinder, and the servo cylinder that you have in the picture in this particular case is a hydraulic, like the servo cylinder that you have on the screen right now. Yes, we are going to integrate all of those equipment in the autopilot system. And one other element that we are going to introduce additionally is the hydraulic pump or power assisted unit that right now we are going to talk about that unit. I am going to explain something. You remember in your car, if your car is off, what happens when you try to move the wheel? It's hard, no? Yes, you can move it, but it's too hard. What happened immediately you turn on the engine? What happened with the steering? Oh, it's completely soft. Yes or not? In your car, if you try to move the wheel right now, you can, but it's too hard. When you start the engine, immediately the engine is running, the steering system is soft, and you can move the wheel in both directions easily. This is possible in your car because in your car, you remember that pump? The hydraulic pump? This hydraulic pump, that pulley is connected by the bell with the crankshaft of your engine. And this pump interrupt one of those lines, cut it, one of those lines, and this pump is located in series. This pump is located in series. I interrupt any line, I cut the line here, and I insert my pump in series. And right now, my pump is connected with the bell on the crankshaft of the engine. Immediately I start the engine, my pump starts, and my system receives extra pressure on the system. And right now the system is completely soft in both directions. This is the pump that you have in your car. This is the power assisted unit in your car. This is the power assisted unit in your car. This is a mechanical power assisted unit. It's mechanical because it's moved by the pulley with the bell connected with the crankshaft, and immediately the crankshaft is spinning, the pump produces high pressure. This is the reservoir. You added the oil here, you remember? You added the oil here, and the body of valves is located in front of this. This is similar to this one. This is similar to this one. Hydraulic mechanic pump. Very similar. And this is the reservoir where the oil is located. Yeah, when the pump is spinning, you send hydraulic fluid with high pressure in the system. Yes, my friend. If you don't have power assisted unit like this, the pressure of the system is 35 psi. When you introduce the power assisted unit, the pressure increase until 60, 70 psi, depending on the manufacturer. Yes, you produce extra power on the fluid, and of course, right now, the movement of the fluid is at higher speed, with high pressure, more pressure, and right now, the system is operated easily. This is the situation that you have in your car. For that reason, when you turn on the engine, the power steering system is soft. When you turn off the engine, the power steering system is too hard. That's okay? All right? And this is the system, and this is the mechanical power assisted unit. Okay, in your boat, you can install pumps like this on the engine, but the hand is located far from the engine. In your boat, the hand is located. Look at this. This is the helm, and this is the engine. Look at the separation. It's 20 feet, 25 feet, 50 feet, depending on the boat. It's too much distance. For that reason, the recommendation is install other power assisted unit, not mechanical, electrical, like this. This is the power assisted unit, mechanical, 12 volts or 24 volts, depending on the boat. Yeah, there are boats configured in 24 volts. The power assisted unit is 24 volts. There are boats configured in 12 volts. The power assisted unit is configured in 12 volts, depending on the boat and depending on the battery bank. Okay, the power assisted unit introduce extra power on the system, and right now the movement of the wheel is pretty soft in both directions. All right. I can install my power assisted unit without autopilot? Yes. I want in my boat, like the boat that I have in the picture, the boat that I have in the computer right now. This is the helm, and this is the engine outboard in this particular case, but you can install with inboard, it's actually the same. And I am going to introduce my power assisted unit, and the procedure is exactly the same like with the reservoir. You cut the port line, you cut the starboard line, and you introduce the power assisted unit in series with the port line and starboard side. The dot line located in between this one in the middle is the return line. Okay, I can install here the power assisted unit, and here in this area the reservoir. Both of them should be located in series. You cut it port and starboard lines, and you insert the power assisted unit in series. Don't forget, quiz question. In series. All right. This is the procedure. It's very, very simple. We are going to refresh. I have the port side and starboard side lines. I cut the lines. I insert my reservoir. I continue with the lines, port side and starboard side. I cut it again. And right now I insert my power assisted unit. And after that I continue with the port side into the cylinder and starboard side into the cylinder. And right now my system is ready. My system right now have a reservoir and an electrical power assisted unit. Okay, that power assisted unit can be installed isolated like this, and I install a power switch like this, or need to activate the pump. When I start my engine, I activate my pump, or you can install that unit connected to the ignition switch in the position ignition. What is the color of that cable? Yes, purple color. And you install in the ignition switch, immediately the engine is running, that power assisted unit start, and the system is soft. When you turn off the ignition switch, the power assisted unit is turned off, and no more power. In this side of the power assisted unit, we have the port side, the starboard side line connected directly into the cylinder. This is the regular hydraulic cylinder, and this end of the cylinder is connected with the rudder arm. This end is connected with the rudder arm. Port side starboard side, and this is the return connected with the return on the reservoir. If you check, there are two ports on top of the port side and starboard side. Those are the bleed ports. In order to bleed the air, you move the wheel in both directions and you bleed the air. Those are the bleeders points. Those are the bleeders points to bleed the air with the appropriated range. The bleed points, port side, starboard side, and this is the return. And the unit is 12 volts or 24 volts, and the unit can be connected, isolated with a switch on off, or connected to the ignition switch in the ignition position, purple color, or this unit can be connected on the autopilot unit. That's your decision, but normally is isolated. Alright? The hydraulic power pack or electro power pack of the power assisted unit is exactly the same, and is also connected. It's exactly the same like the power assisted unit. This is the power, the hydraulic power pack is electro hydraulic, because normally there are two cables, one cable for power and other cable for data. That cable is connected in the NMEA 2000 backbone. Alright, exactly the same like this. Correct. One cable for power and other cable for data, and this is the unit. If you check the unit have three inputs and three outputs. Exactly the same like the previous unit, that we have three inputs here, and three outputs over there. Exactly the unit that we have here. We have three inputs and three outputs. Alright? Exactly the same. Alright. If I use this electro-hydraulic unit of 12 volts or 24 volts, that unit, one cable is connected to the power and the other one is connected to the NMEA 2000 backbone, or is connected directly into the computer. If you check the computer, this is the computer of the autopilot. In the computer you have one position for power, positive and negative, and other position for the motor. This is the motor of the drive unit, position A and position B. It's exactly the same like the new computer for autopilot system. In the new computer for autopilot system, you have the rudder sensor, the flush gate, and this is the power, positive and negative, and this is the motor, position A and position B, for the power assist for the hydraulic unit. Okay, it's simple, and this is the unit that produce the extra power in order to move the actuator, the servo actuator forward or reverse, and steer the boat in the direction that you want. I hope that be clear that concept. Alright, this is the power assisted unit, and this is the connection. Let me show to you. It's very, very simple. We have the helm here with three ports, and one port for port side, starboard side, and the middle one is the return. In the port side, I install the T and I go directly into the hydraulic unit, and in the other T I go into the other side of the hydraulic unit, and the middle one, the return, connected with the pump. The middle one connected to the pump. Normally I install a T over there, connected here with the T into the reservoir, and this is the return on the reservoir tank, and the reservoir tank with the hydraulic unit here, with the valve for the air over there, and with the gauge for the pressure here. That's okay. This is the typical installation. I have another one here. This is nice because it's one helm on the fly bridge, other helm on the pilot helm, and look, they have the port side the starboard side, the middle one, the return, and in the port and the starboard side I install one T here, other T over there, and I go directly into the hydraulic unit or autopilot power unit or power pack autopilot unit. One side for a starboard side and other side for a port side, and the middle one for the return. Perfect. And this is the procedure to connect. Is simple. The most important part is when you prepare a boat to install the autopilot system, verify what type of hydraulic lines are used in the boat, what type of fittings are. Prepare the fittings, prepare the connector, prepare extra fittings, extra connectors, double. Prepare extra lines, because in case that those lines are broken, you can replace the lines. And when you have all the fittings prepared, cut it. Never cut it and after that try to find the fittings. No, you need cut it, and you need to immediately install the new fittings and insert the equipment that you want to install. Normally when you visit a boat, in the boat you found the hydraulic the reservoir, but probably no electric unit. You need to install the electric unit, and in some cases the electric unit and the reservoir. For that reason you need to prepare the lines. You need to make a drawing before of the installation. Make a drawing where should be located each element, how the distance in between the equipment and the cylinder, the equipment and the power assisted unit, the fittings, prepare the fittings, prepare tabs in order to close the lines for a couple of hours while you do the flares or you do the connection, and after that install everything. Immediately you finish with the installation of this and the installation of this, the next step is bleed the system. You need to move the wheel in both directions and bleed in this direction. Move the wheel in the other direction and bleed over there. In some boat you can install the bleeder here or here, and you bleed here or here. In my class of hydraulic systems, in the auxiliary book, I explained that procedure over there or here. Today is not extensive, the explanation about the hydraulic system, because the episode is dedicated more to the autopilot system, not to the hydraulic system. If you wanted more attention on the hydraulic explanation, go into the videos in the I don't remember the number of the episode in our Marine auxiliary book, the episode related with hydraulics. I explain in details how to calculate the pressure of the piston, the fluid, the flow, everything. Alright, but this is the procedure. We are going to refresh the process. I want to install an autopilot system in my boat. There are autopilot systems for power boats, and there are autopilot systems for sailboats, and there are autopilot systems for boats with a mechanical steering system or hydraulic power steering system. But at the end of the day, all the systems operate exactly the same. Okay, what I need installed in my boat, I need install the screen for the autopilot. Suppose that I have a boat with a no NMEA 2000 backbone. It's an older boat, and I want to install the autopilot isolated. Exclusive autopilot is not integrated with any NMEA 2000. What is the procedure? The procedure is very, very simple. When you buy the kit for the autopilot system, you receive the computer for the autopilot system. You receive the sensors, the rudder sensor. You receive the compass or heating sensor. Depending on the model, this is for connection directly into the NMEA 2000. This one, no, this is connected directly into the computer. You receive the computer, and you receive the electro servo cylinder or hydraulic servo cylinder, depend of the what is your decision. If the boat is a small boat, less than 32 feet, I recommend electro servo cylinder. If the boat is bigger than 32 feet, power boat, the recommendation is hydraulic, electro-hydraulic, servo cylinder, like the cylinder that you have on the screen right now. Okay, those are the elements that you receive, and also you need install the reservoir, and you need install the hydraulic unit, the power unit. Okay, and what is the procedure? You need follow the lines, the port side and starboard line in between the hand and the cylinder, and you need two interruptions. One interruption to introduce the hydraulic servo, the hydraulic power steering reservoir, and you need other interruption to install the electro-hydraulic unit, the power unit. Okay, in order to do appropriate those interruptions, you need to prefabricate the fittings and the connectors and the lines, especially according with the distance, the line that we are going to use between this and the cylinder, and in between the reservoir and the power unit, and in between the power unit and the hand. Probably you need to fabricate those lines and those lines, because right now you only have this line and this line. Originally in my boat, the connection in between the hand and the cylinder is with the orange lines. The orange lines are connected directly here and here. Right now I disconnect the orange lines, I put the orange lines here at the beginning of the reservoir, I fabricate those extra lines and those extra lines. That's clear in terms of hydraulic system. And right now, suppose that I am going to connect my power assisted unit in the end. I connect that power assisted unit with a separate switch, or connected with the ignition switch on the hand, doesn't matter. Or if I am going to integrate with the Autopilot system, this element have two cables, one for power and other for data. Okay, the power connected in the power position, and the data in the position A and B of the computer. That's not complicated, it's simple. Alright, the sensors. The sensor for the Autopilot system. The rudder sensor. The rudder sensor work in parallel. With the arm of the rudder. Okay, this sensor, the cable, the wire enter directly in the position rudder. Here, the colors are blue, green, red, and the drain for the bonding system. Okay, the rudder sensor is connected, and now the compass, the heating sensor, is connected here on the flush gate position with the same color code. Is blue, yellow, green, and red, and you follow the colors according to the computer, right? Those are the sensor. This is a compass, heating sensor, rudder sensor, and the motor, the power, and now the connection in between the computer and the main screen, or in between the computer and the backbone directly. The computer and the backbone directly. If the system have a NMEA 2000 backbone, I connect my computer with the backbone. If not, I connect directly my computer into the screen. And right now I have the screen, the computer, the sensors, and the power unit integrated in this screen separated. If the boat have a NMEA backbone, I have the computer integrated with the backbone, the computer connected with the auxiliary screen, and the computer connected with the main screen. In other words, I have two screens to operate the Autopilot. I have one computer, that's the computer of the Autopilot, and I have the sensor, rudder sensors, and compass, both of them, and this is the servo cylinder. The servo cylinder could be electrical or electro-hydraulic, depending on the system. And it's simple. Those are the connections, and this is the procedure. Right now, in the next chapter, I am going to explain the GPS, and after that, when I finish the explanation of the GPS, I am going to integrate the GPS with the Autopilot in order to explain how the Autopilot works with the signal from the GPS. And we are going to learn a couple of tips to do the troubleshoot when the autopilot is working erratic or not working. But in general terms, this is the procedure to install an autopilot in any type of boat. I hope that you enjoy this video. Follow my webpage, follow my videos, my YouTube channel, subscribe in the YouTube channel, and you found it videos for diesel, for gasoline, for hydraulic, for corrosion, for for any type of systems in the boat. You found it videos in my YouTube channel.